How's it going, students? So let's take a look at how to solve these train collision mystery problems. A train is speeding down a railroad track at 80 kilometers per hour when suddenly the engineer sees a truck stalled at a railroad crossing ahead 400 meters away. The engineer steps on the brake and is able to generate a force of negative 100 kilonewtons. The train has a mass of 142,857 kilograms. So number one, how long does it take the train to stop? And number two, did the engineer brake in time to avoid the collision? So let's take a look at what we do first. So step one, you see this kilometers per hour. We need to convert that to meters per second. So let's take a look at how we do that. So step one, convert the velocity. So we're going to write it out. So we have 80 kilometers per hour. And then what we want to do here is start with the top unit. So we have kilometers, so we're going to multiply by the conversion factor. And so the conversion factor of kilometers to meters is going to be 1,000 to 1. The first thing we have to ask ourselves is which unit is at the top? And if the unit is on the top, then the unit has to be on the bottom. So right now we have km on the top. So we're just going to put km at the bottom. And then we're going to put what we're trying to convert to at the top. So we say meters. The next step is to write out what is the ratio between meters and kilometers. The ratio is 1 kilometer for every 1,000 meters. So we multiply that across, we're going to get 80,000 meters per hour. Now, that's not what we ultimately want to get to. We want to get to meters per second. So we just continue our conversions. And so what we do is we multiply now to get rid of the hours and convert it to seconds. So we do a similar thing. We're going to put the unit. So right now, hours is on the bottom. So hours needs to be on the top. And then what we can do is we can think what units relate to time, and we can get to minutes. So once again, we ask ourselves, what is the ratio between hours and minutes? In 1 hour, there is 60 minutes. And I'm kind of running out of space, so I'm just going to continue this conversion. So I'm going to multiply by the conversion factor once again. And so that is going to be 1 minute. And so that cancels out. And that's 60 seconds. So once again, it's just the ratio. Now let's go ahead and check that all our units canceled out. Kilometers on the top, kilometers on the bottom. Okay, that looks good. Hours on the top, hours on the bottom. That canceled out. And then a little bit tough to see here, but you can kind of make it out. Minutes on the top, minutes on the bottom. So when we multiply all our numerators together, we're going to get 80,000. So this equals 80,000 meters divided by, we multiply our denominators, 1 multiplied by 1, multiplied by 60, multiplied by 60. That's going to give us 3,600 seconds. So when we divide our numerator by our denominator, whatever that value is going to be our meters per second. So let's do that calculation real quick. 80,000 divided by 3,600. So our answer is going to be 22 meters per second. So 80 kilometers per hour when converted to meters per second is 22.2 meters per second.